So IPv6 is an 128-bit addressing. IPv6 is divided into 8 octets, and IPv6 is written in hexadecimal format. When you select hexadecimal, we'll be having 0 to 9 and A to F. And here IPv6, every octet contains 16 bits actually. Every part will have 16 bits will be there. And when you select a /64, the first 64 are the network bits, and the next 64 are the host. And the same IPv6 address also can be written as 2019 FD08. When you have a 4 zeros in one octet, we can write a single zero. Again 4 zeros with a single zero. 4 zeros, 4 zeros, 4 zeros. When the decimal numbers are hexadecimal preceded with any zeros, we have all zeros are there. Before that, also it can be eliminated and we can write a single one. And even in all octets, we have all zeros are there. And this is written with a colon. So 2009, 2019 colon F08 colon 1. So here you can see I have one octet, second octet, third octet. 3 octets I can see, but 5 octets are of all zeros actually. 5 octets are all of zeros can be understood. IPv6 we don't have any classes. We don't have any classes like class A, B, C, D, E, and class IPv6 also we don't have any subnetting also actually. We don't have any subnet mask. But when you are going for our IPv6, we have like an IPv6 communication types. IPv6 does support unicast communication. Unicast is like one-to-one communication. And also IPv6 supports multicast routing. IPv6 supports multicast routing. And also IPv6 also do support any casting. Okay. But IPv6 does not support the broadcasting. IPv6 does not support the broadcasting actually. No broadcasting is available in IPv6. No broadcast. And also actually we have some technologies like no NAT. We don't require NAT to be configured. This NAT is like network address translation. I'll do take. NAT is not required actually. NAT is not supported because in IPv6 we have like a 340 trillions of IP addresses are there. In the world, just we are only 8 billions of people. So altogether we have a 340 trillion of IP addresses are there. Whereas in IPv4 we have just only the usable is 2.3 trillion billions of IP. So that's why they understood the shortage of IPv4 in 1983 and they introduced the IPv6. And most of all service providers in the world, internet service providers, most of IT companies, they are using IPv6. And IPv6 has its own features like it has inbuilt IP security. Yeah, it does not support NAT. It provides some good security within the address of the IPv6. Because if one device is using IPv4, if one device is using IPv6, and if there are some hackers to try to take an attack on IPv4 and IPv6, IPv4 headers are not being, it's easily it can be decrypted, and they can try to do an social engineering attacks on IPv4, but not on IPv6. Of course, IPv6 has a larger address space, and it can be compressed. And IPv6 addresses, again, they have divided into something like any link local addresses. We have a link local addresses. Again, we have a global addresses. And again, we have a organizational. whenever you enable IPv6 on a device, and when you have to enable on the interface also, like fast Ethernet, gigabit, you have to enable the IPv6. So when you enable the IPv6 on the interface, automatically and a link local address will be created. A link local address will be created automatically. And when you are going for like any global, link local addresses will be created. Okay. And when I'm going for creating a global addresses are the routable on the internet, and it's like public IP addresses. But whereas the organizational, it's just like in a private, they are non-routable. They are assigned the IP addresses within the LAN only. We don't use the organizational, and we don't use link local addresses. Link local address as a local significant IP address it is. So always we use the global. And the global addresses, they will start with the number 2. So when you are going for the lab, you take a router 1, this will take just 2 routers only. And you take some 2 PCs. So connect your PC to the switch. PC to the switch. So for this PC, let's give the IP address 2000 colon F308 colon 1. Let's use this 2001 colon F308 colon 1 plus 64. Okay, plus 64. Of course, I'm taking only 3 octet. All 5 octets consider they are of all zeros. And for the serial, I'll give like a 20. Let's take 2040 colon F308 colon 1 slash 64. And here we will let us take 2040 colon F308 colon 2 plus 64. So this is our router. And before going for the router, let me assign the IP address for the pieces. So we are using not IPv4, we are using IPv6 here, IPv6 configuration. Because the gateway is in 2000 colon F308. So let me assign like this is 2000 colon F308 colon 2 plus 64. Gateway you see here down is coming up 2000 colon F308 colon 1. Because and this is the second PC. This is 2000 colon F308 colon 3. Sorry, not the
IPv6, yeah.
2000 colon F308 colon 2 plus 64. 2000 colon F308 colon 1. This is 2001. Okay. Of course, they are in the three different networks. They are, because the network bit should be the same. Last 24, first 64 bits are the same. This is 2000. That is 2001. They are in different network. So 2001 colon FD08 colon 2 class 64. Host name R1. Interface figure 0 by 0 by 0. No IP address for IPv4. IPv6 enable. IPv6 enable. IPv6 address 2000 FD08 colon 1 class 64. No shut off. Interface serial 0/1/0. No IP address. IPv6 enable. You have to always enable IPv6. Then IPv6 space address is 2040 colon FD08 colon 1 class 64. You must give the no shutdown encapsulation PPP. I give the command clock at 6000. Then end. So when you are configuring the serial IP address, you have to go to configuration mode, interface serial 01 by 0, IPv6 enable. We're enabling IPv6. When you define the IPv6 address, no shutdown. And the full command is encapsulation. And I'm using PPP, point to point protocol. Clock rate, RATE, clock rate, full command. So I'm giving shortcut here. So it's enabled. So whenever you're using IPv6, the best practice is you have to go to the configuration mode, and I need to enable IPv6 unicast routing. It's very, very important command. If I'm going for IPv6 space, question mark, what type of routing it can support? The IPv6 unicast routing must be enabled. Then only it can route the packet. Then only we can configure dynamic routing protocols. One of the most important command. Because by default for every router, it is enabled with IPv4, not on IPv6. So if I'm going for router 2, CLI, click no, enable config T, host name is R2, interface giga 0 by 0 by 0, no IP address, IPv6 enable, and IPv6 address, it is 2001 colon FT08 colon 1/64. No shutdown. The link should be up. The same manner, interface serial 0/1/0, IPv6 enable, no IP address. When you type no IP address, no IPv4 actually. Then you define the IPv6 address. IPv6 address, it's 2040 colon FD08 colon 2/64. Then no shutdown. Encapsulation is PPP, and define the clock rate. CL clock rate is not given here, as this is DDE. Then If you want to ping here, type ping. Router 2 it is 2040 colon F308 colon 1. I'm getting a reply. So I'm able to ping from the serial to serial. Okay. And we do IPv6 unicast routing. Let me do here also. IPv6 unicast routing in router 2 also. Now if I'm going for this router 1, if I'm going command prompt P, it is 2000 colon FD08 colon 3, or let us ping to the router 1. You see in IPv4, every packet is broadcasted in the LAN and it is going to be request timed out. So from second packet onwards, you get reply. No broadcasting here. I have a 2, 3. Only 3 IP addresses are there in the LAN. 2000 FD08 colon 3. So the request timed out is no. What happened? Okay, this is 2 1. And this is how it is possible 1 2 3. So there is a duplicate address. With a 3. No, so when you send IP, is directly getting a reply. But I cannot ping from here to 2001. The required routing, yes. We have like an 2001. We cannot get reply. It says destination host unreachable. So you require something called routing. In your previous classes, in the routing type, you understand the routing are of 3 types: static, dynamic, and default. So what is a static routing, sir?
IP
Tell me.
fixed IP address.
Yeah. So fixed IP address, we are making a route to the network route actually. Not a bit in the time. So when you're going for routing in the last classes, later we'll be learning also. So routing is in a process of sending the packets to the destination by selecting best path. Routing it is a process of sending the packets to the destination by selecting best path. Routing are of 3 types. You have a static, you have a dynamic, and again we have a default. Static routing is a route which is manually configured by the administrator to reach known destination. So I should know the destination addresses. So only for the when I know the destination network address actually, I use static routing. But whereas for the default routing, the default route is also a route which is manually configured by the administrator to reach unknown destination. When you don't know the destination addresses, you use default routing and you give 000 space 000 and you define the next hop. define the next hop actually. Whereas in static, you define the IP route is the command, then we give the destination network ID, This I am bringing back of Oliver routing information, destination network ID, we have a subnet mask, and we give something called next hop. Actually, this is a syntax to configure the static routing. So static route is for known networks, default route is for unknown destination. When you know the known destination, you can prefer static routing, and we use this way to configure it. And by default, the administrative distance for the static route and the default route is 1. The administrative distance is 1 only. So here, if you want to configure like static routing in the router 1 I go to configuration mode, I need to define IPv6 route. IP route is for IPv4. I need to define IPv6 route. Or if I say like do show IP interface brief, you see, oh sir, I assign the IP address for the interface giga 000 and serial also. Serial 01 by 0 voda or serial 01 by 0 also I assign the IP. But I'm not getting the IP address here. Because when you type IP, it's for IPv4 only. IP is for IPv4. So if I want to see for IPv6, do show IPv6 INT brief for IPv6. So I have a giga 000. You see, I said link local address is created. Whenever you enable IPv6, when you enable IPv6 protocol on the interface with the MAC address of the device, a link local address is created. This is called link local. This is IPv6 address. And for giga 001, why no link local? Because IPv6 is not enabled in that. We enabled IPv6 only on the 01 by 0, giga 000. So you see the interface addresses using interface brief. If you give the command like do show IP route also same, that's for IPv4. You have to give the command do show IPv6 route. So when you type the command do show IPv6 route, the addresses like what you have, these are the codes, like what type of routing you have done, everything will be displayed. So in the router 1, if I want to do with IPv6 static route, IPv6 route, my destination for router 1 is router 2 network. It is 2001. So I need to define IPv6 route 2001 colon 308 colon 0 slash 64. This is the network ID. This is the subnet mask. After that, we define the next hop. Next hop is 2040. Router 2 IP address 2040 colon FD08 colon 2. That's it. No need to give the slash 64. In the case of router 2, if I'm going for here IPv6 route, it is 2000 colon FD08 colon 0 plus 64. Network ID, subnet mask. Then the next one, next hop 2040 colon FD08 colon 1. That's it. This is how you make the static route. And after you make the static route in the router 1, if you give the command show IPv6 route, you'll be having letter called yes. And S indicates that this is the static routing. S is for static. Now, before this computer was unable to ping to the other branch, 2001. If I give just up arrow and if I give enter, now there is a routing, we are able to reach. Also, I can ping to the 2 also. I can ping to the 1, that is the router. So if you see here, if I'm going for in the route in the page, if I'm going for the Google, if I give the command like what is my IP address, of course yes, ISPs they have my the Beam Telecom, they give me the IPv4 as well as IPv6. 2406 colon B400. So I have 1, 2, 3, 4, 5. 5 octets are there. 3 octets are all zeros are here in between this. Between 2 there are 3 zeros. Between D3 there are 2 zeros. So by seeing the address I can understand that there are some zeros are being compressed over here. So now this is a like static route. It's a route which is manually configured by the admin. You can say to configure static routing. So if you want to remove the static routing, same how I need to go to configuration mode, type the command no IP route, control A, no IPv6 route. I'm sure that you're going to give the next stop. That's it. To remove static routing, no IPv6 route. In the router 2 also let me remove it. No IPv6 route. So once you remove, and I'm sure that this species again they cannot communicate with other batch. If I'm trying to ping 2001 colon F08001, this says destination host and reachable again because there is no routing. So then when you are going for like any default route, what is a default route? Default route is also a route which is manually configured by the administrator to reach unknown destination. Unknown destination means what? You are working as an administrator in Hyderabad. This is your Hyderabad router. This is your US router. So this router is there in Hyderabad. This is in Chicago. Now I don't know the Chicago network IP addresses. I don't know the what addresses there in the US they have. But I need to route. I need to route the packets. So in the IPv6, for example, to make the default route, again we go to configuration mode. We define IPv6 route because when you see the routes, you need to understand. I don't have any IP route in the case of IPv4. We give 0000. So here we give colon. All 128 bits are there. All zeros. All 128 zeros. Slash 0. With all networks. Then we define the next hop. I don't know in IPv6 why they have been simplified so much manner. F308 colon 2. So whoever IPv6 is using in the world, my router can route the packets, can reach them. So my mobile has IPv6. My computer has IPv6. Your computer also has IPv6. And my ISP will route that particular packet. If I'm trying to ping to your IP, it is going to route to your the next stop. The next stop addresses will be routed, and it makes sure that it is going to reach from the source to destination. It's easy one, no? IPv6 route colon/0. Then you define the next stop. is to configure default route. The same manner in the router 2 also. IPv6 route, IPv6 route. I give ::/0, then 2040 F008 and ::1. So 1 is the next hop for router 2. This is the IP address of router 1, serial. Now there is a default route is configured. Any type of routing should be there, whether it's static, whether it's a default, whether it's a dynamic, to make communication between multiple destinations. So now if I give enter, and if it's able to ping again. If I do the 2001 is the network of, the US. This is 2001. And again, from here, if you want to ping 2000, yes, sir, try to ping, it's 2000, FD08, 2. And 3. Do you have the IP address of 4? No. So 4 cannot be reached. You get request come down. And in the same manner, if you want to remove, control A, go IPv6 route. In order to give the next hop, you can verify do show run. You can see how IPv6 address has been assigned for an interface. In your working area, you can verify whether you're using IPv4 or IPv6. Sometimes we have both IPv4 and IPv6 will be there. When you have the IPv4 and IPv6, both routings are done. That is called dual routing, dual communication. And there is a routing information here. So also I can copy no IPv6 route until this. Yes. So this is to apply, then this is to remove. Likewise, already I removed it. Likewise, if you are going for the EHRP, just you know what is EHRP, because in your IPv4 I discussed. Salam brother, I will discuss with you later. Just you know just how to configure it. Just we are configuring EHRP routing protocol. So EHRP is an IGP, a link state dynamic routing. It's an IGP or distance vector dynamic routing protocol. The Cisco proprietary until 2013 it's developed. It's deployed. The Cisco proprietary until 2013, but it has been standardized. Automatically, it's going to advertise its network. Here in IPv6, the beauty of the IPv6, because we enable this IPv6 address in your load balancers like F5 and all the firewalls they are supporting with IPv6 now. Okay, and we need to enable this IPv6 protocol on the interface level. There is no advertisement, like no network ID. Not advertising the networks manually, no. So if I'm going for router 1, remember we have a router EHRP1 is the command in IPv4. But before that, I need to define IPv6. IPv6 router EHRP1. And you see you are in the router mode here. And every router will have its own router ID. Router ID I am giving 1.1.1.1. EHRP router ID. Yeah, EHRP router ID, and you must use the command no shutdown. So sometimes the protocol mismatch of mismatch of the IDs. Sometimes the protocol itself can shut down. So it's better that we must give the no shutdown, not in the IPv4, only in the IPv6. So if I'm going for now interface, your serial 0 by 1 by 0. So I need to enable the EHRP on the interface. You type IPv6 space EHRP space 1. That's it. Interface giga 0 by 0 by 0 IPv6 EHRP1. And that's it. IPv6 router EHRP1. Then we define EHRP router ID 111 no shutdown. This is configuring the protocol, then enabling the EHRP on the interface. That's it. So easy. So in the router 2 also, if I do want to do the same, going for router 2, I say IPv6 or IPv6 ROET router EHRP space 1. EHRP router ID, it should be in the same. So the router ID should be different here. 2 must be in the same autonomous system 1. Then enter. Close it down. Then interface serial 0/1/0 IPv6 EHRP1. I'm getting some urgencies. Interface giga 0 by 0 by 0. That's it. Then end. So this is how you configure the static default and EHR. So if I'm going for in the router 1 now, there is some urgencies are happening. Show IPv6. Show IPv6 EHRP. EHRP space neighbor. Neighbors are there. Show IPv6 EHRP route. Show IPv6 route otherwise. Show IPv6 route EHRP. No? No route. So we have the interface command, neighbor command, topology. Okay, anyway, let us. If I'm going for show IPv6 route, we'll have a D route. So this 2000 for an FD000. This network is advertised. Show IPv6 neighbors we have done. Show IPv6 router EHRPS. Oh, it's in the IPv4 should come. This stuff is there. Yeah. So show IPv6 EHRP topology. Like how many networks we can reach, everything will be there. All the routes will be passing. And even after configuring AGRP also, I should be able to communicate them. This was for today's class. Okay, you can take this pic. So in yesterday's
class, I have doubt. I have open in my. Hey,
Yeah.
Chandu. Yeah.
You
Can
want
I
to
share the? Yeah, I'll share it.
what was yesterday's lab switching?
Yeah, switching last class. You are able to see my screen now? Okay. Yeah.
The lab. Oh, what happened? Both interfaces are getting down.
Yeah.
Did you enable any port security like that?
I just introduced like VLAN 11, playing with that, and then I don't know why it's not. I want to communicate between these two switches. Why it's the communication is failing? I don't know.
Check for on.
In this.
Did you make the trunk interface bigger giga 0 by how you
that trunk only I'm not clear. Much clear.
How?
So yeah.
Switch for trunk native VLAN level. Port number 1 is in the native VLAN of 11.
Yes.
You enable the port security MAC address sticky. Good. But where is fast Ethernet 0 by 1 is connected? No device is connected to the fast Ethernet. You do switch down switch or a first switch?
This one. Switch 0. Switch
But
0
the
here.
fast Ethernet 0 by 1, nobody is connected. 0 by 2, also is in VLAN 1, native VLAN 11, mode access, MAC address sticky.
I added that range, internet interface range.
Okay. Go to the, see, you disconnect that computer to the giga 0 by 1. The ports, the cables are not connected proper way, you see. Giga 0 by 1, giga 0 by 2, you have to make a trunk.
Okay, 0 by 1 and 0 by make a trunk. Okay.
That should be connected to the switch to switch. Just show the switch again. Again type the show run. See the giga 0 by 1 and 0 by 2. If you make a trunk interface cannot be connected to the PC. Go down, down. Not the fast Ethernet 0 by 1, giga 0 by 1. Yeah. It will be at the end last.
Yeah, it will be in the last, right? Yeah, here.
Now you see giga 0 by 1, you switch port more trunk you make. How a trunk port can be connected to the PC? Yes or no?
Yeah, can you fix this? I'll just watch and learn.
Same, just go to the you have to remove all connection. You have to delete all the network connections between the switches and the computer. Select the delete option, take the delete. Odd one. Yeah. Delete the cable between the computer and the switch.
Oh.
Yeah, sir. Now you can give Control Z, Control Z.
Okay, undo. Okay.
And now you select the cable. Click on the cable will be deleted.
Okay.
Delete that. Also delete down one also, I'll tell you. Delete this.
Okay.
Now you select, take the cable, connect this PC to the switch fast Ethernet 0 by 1 because hosts are connected to the fast Ethernet port. Take the third one. Third one is connect to the PC. To the switch fast Ethernet 0 by 1.
Okay.
Now connect switch to switch giga 0 by 1 giga 0 by 1. Third one. Sorry, fourth you have to select.
Fourth. Oh, okay.
Switch to switch you use cross cable. The trunk is between switch to switch.
Pardon?
Giga 0 by 1. Trunk ports are between switch to switch.
Yes, yes. Because that's a communication for the VLANs,
Switches.
inter-VLAN, right? Yeah,
So, yeah,
switches.
to carry the VLAN traffic.
Okay. Are you able to hear me?
Yes, yes.
Okay. Yeah.
Now it's taking time to come up.
Okay. Enable mode.
You can go to the PC and
Config.
yeah.
Okay. So run. So here, should I copy that old one here?
Now you see here in the switch one, not like copy. You see there is the VLANs are in native VLAN of 11. Here
Yeah.
the VLANs are not created.
Yeah, I'll copy this here, right? No.
No, this is the second switch down one.
Yeah, down one, switch one.
So this switch, this PC and that PC, if they want to communicate, they must be
Yeah.
in the same VLAN.
So VLAN 11, right?
Yeah. Then you have to configure VLAN 11. Add that interface in the VLAN 11. And the giga 0 by 1, here giga 0 by 1 gone down because it's violation. What violation? Check go show run. Check in the second switch show run. See whether you made that giga 0 by 1 trunk or not. Show run. Go down. Down. You see giga 0 by 2 didn't make a trunk. 0 by 1 also didn't make a trunk.
Okay,
And
here.
there you enable the port security or not enable. Let it be in the VLAN 1. Don't go for native VLAN concept.
Okay. So what is the difference between native and
Native VLAN, like if you want to customize the VLANs, then using the VLAN 1, we can define native VLANs actually. Where the trunk should be working.
so what should I like? Yeah.
Now you have to create everything again. You have to create the VLANs. You have to enable you have to configure the trunk on the giga 0 by 1 and 0 by 2. You have to go to configuration mode, interface range, giga 0 by 1, 0 by 2, switch port mode access, switch port mode trunk. You have to do slowly practicing our videos.
Yeah, the problem is I'm starting late in the video, so I'm missing out the first part. You have the like sequential videos for VLAN and trunks?
You
Yeah.
Shafi is not there. Interface giga 0 by 1, yeah, interface range giga 0 by 1, 0 by 2.
Okay.
Because in the first, how I told how to make a trunk, create a trunk, add the interfaces. Then
Okay.
making a, yeah, create a VLAN, add the interface on the VLAN. Then trunk
Okay.
concept. Switch port
Okay.
mode access. Then switch port mode trunk.
It's not coming up to my muscle. Should come to my muzzle, right? The command lines. Okay. Now I do show interface trunk.
Do show. Show is in privilege mode.
Sophia?
On the first switch, giga 0 by 1, giga 0 by 1 is working on the VLAN 1, VLAN 11. This is on the second switch, giga 0 by 1 is in the native VLAN of 1. You see the last one native VLAN. They must be in the same VLAN.
Okay.
Then only it will function.
Okay. I got it. Because I configured the 11. Okay.
Yeah.
Okay.
Okay then. So
Okay. Thank you, Chandu.
take I have a two switch. We have something called like BPDU guard. BPDU guard. Now when you are going for like BPDU guard, actually the switches they send BPD messages. When you are connecting giga 0 by 1, giga 0 by 1, when you connect giga 0 by 2 to giga 0 by 2, the switcher sends the BPD messages. Whenever you enable port fast on the access layer switch, consider maybe you configure the port fast. Port fast, remember the port fast? I have the PC1, I have the PC2, and I have PC3. So these are the computers. Computer 1, computer 2, computer 3. See, when a computer is connected, according to the STP, the port is going for listening for 15 seconds, lining for 15 seconds, then it is going for forwarding for 15 seconds. No, actually after some 30 seconds only the interface is coming into forward state. I go to enable config T. Spanning tree put fast default. So when you enable this spanning tree put fast default, now later whenever any computer is connected, automatically the port will enter into the forward state. No listening, no learning. You see here, it is green color direct. But when you configure a trunk, also you make a trunk in the switch to switch interface range, giga 0 by 1, -2, switch port mode access, switch port mode trunk. Also in the second switch also I need to configure the trunk. Switch port mode access, switch port mode trunk. Good. Let it come green. So anyway, we made a trunk. By mistake, one day, the one administrator came and is taking a trunk interface from the switch and is connecting to the port which is enabled with port fast. So they send the BPD messages that causes this interface to go into error disable mode and the port is going to shut down. They make say bridging loops by default. Never you should connect a port fast enabled switch making a trunk. So now they are not able to communicate. So to avoid this something called, we can enable the BPDU guard, bridge protocol data unit as well. So if I'm going for here, so IP interface brief, the port number 5 and state of how this is bigger 0 by 1. Up and up. BPDU guard is used to guard the trunk interfaces from the port fast as well. But BPDU filter just it will filter the packets. It does not it does not filter the just it is going to filter the BPDU messages only. We have a BPDU filter. Like this, we have in your network will be having like so many distribution switches. We have a distribution switches and also we have the core switch. Remember in your STB, we have like a root guard. Root guard enabled on the root guard command is enabled on the distribution switches to safeguard the root bit switch. Even if you bring a access layer switch, if it is being connecting the trunk, if it is being connecting actually, and even if it has a lower MAC address, this switch should not become as a root bit switch as well. So to avoid that, actually you will configure the root guard.
So in NF, like N7, Nexus 7, Cisco Nexus 7, those are like core switches, right?
Yeah. All
So
7000 series, all 7000 series are the core switches, and the distribution will be like 3000.
Oh, okay.
So this is the main. There are a BPDU guard, BPDU filter, root guard. Then if you're going for like HSRP actually, sometimes if you have the I'll be having a switch. I'll be having a switch. I have two gateways are there, and I have some my LAN. Just I'm taking one piece. I have only one piece connecting to Giga 0 by 1, Giga. I have two gateways are there, and we have the internet. If, for example, there is a cloud. Now we do these things in the GNL, not in the E. or GNS, not in the packet tracer. For example, it's considered it's an internet. So now, if this user want to access internet, this computer is 192.168.1.1. This router IP address is 192.168.1.253, and this is 192.168.1.254. So what is the gateway address I have to give for this PC? If I'm going for desktop IP address, if I'm giving 192.168.1.1, 192.168.1.254, if I give 254, it will go.
Yep.
So if this router is down, again this user will not access internet. Or if I give like a 253, I use 253. But if the router or this router is connected with to another ISP, that ISP link is down, or if this router is down, I will not get internet. So you have some issues because in the production network, surely will be having two routers actually. So here we have some concept called HSRP, first hop dependency protocols, VRRP and GLBP. Okay. So what they do is enable config interface bigger 0 by 0 by 0, no shutdown, IP address can give 191.168.1.253 space 255.255.255.0. Then let me do based on this. Go to CLI, click now, enable config interface giga 0 by 0 by 0, go shut, IP address 191.168.1.250, 254, 255.255.255.0. Now then what happened? What we have to do that? I have to combine these two gateways and create one virtual gateway. HSRP combines multiple gateways together and creates a virtual gateway. So how you do that? I have to go to the interface, configuration mode, interface bigger 0 by 0 by 0. The command is IP standby is a command. So standby, then the group number 10, for example, IP standby question mark. Let us use the group number standby 10. IP, I give 192.168.1.200. Then standby 10 question mark. I gave the IP address, that is the 200. Then I give like something called like an attract. I need to monitor the Giga 001 that is connected to ISP. I need to configure on the second router also. Standby 10 track Giga 001. Standby IP question mark again. There is something called priority. The device which has the highest priority will become as active router or active path. So here this is a 255. Again standby 10 question mark preempt. I will explain this. That's it. Timers let it be the by default. Then end. You know what I give. So if I'm going for in the router 2, there are some warning message came. 150. See here, observe here. Interface giga 0 by 0. I say standby STAND standby space stand, then IP 192.168.1.200. It should have the same. If they must be in the same group, they must have the same IP address. Standby 10 question mark. Then there is a priority. A router which has the highest priority will become as an active. Then the lower priority becomes as a standby. Priority, I get 254. So another one is 255. This is 254. Then I give track to monitor the traffic of Giga 0 by 0 by 1, which is connected to the ISP VD. No priority. Standby IP 10 track. Standby track giga 0/0/1. You don't need to enable preemptive here again, but still if you enable, there is no issue. No track value. So there are some IP we have to give, preemptive have to give. We have to define the track value and so on. So HSRP is a combination of HSRP is a hot standby routing protocol, which is used to combine two physical gateways together, creates a one virtual gateway. The virtual gateway IP address is 192.100. Now I have to give for every computer the virtual router IP, which is 192.1.200 as a gateway for every device in the LAN. Then HSRP is going to choose which is the high priority. I gave this high priority is 255. This priority I gave 254. Then it choose 255 to send and receive the data. In the case 255 is down, then 254 will work as an A data. Then I enable the preemption it is preemption. In the case if the primary is down, the standby, which is called backup, it becomes as active and sends the data. What about the case if this comes up? They should take its position. So that's why we enable the preemption. Okay. And there is a track value, and if you want to define some timers, also you can define the timer. The concept of HSRP. Also, we have something like more than VRRP, and also you have the GLBP. GLBP is used for load balancing of the traffic, supports for IPv6. But here there is no load balancing in HSRP and VRRP. For your information, like HSRP, BBD guard, BBD filter, root guard, code fast. Okay, but our main lab is this for today class. So we'll see you tomorrow. Tomorrow we'll discuss about the which one. Tomorrow we need to go with BGP. We have the remaining BGP, ACL and NAT. So 2 days class. Tomorrow and day after tomorrow. Okay.
Okay, sir.
And after that, Salam bhai, I'll be in the call with you. Okay then. So we'll see you tomorrow.
Sure. Thank you.
Okay, sir. Bye, sir. Thank you.